Hey everyone, and welcome to our GTC session on how the TAO Toolkit can supercharge your AI model development process. My name is Akhil Doka, and I'm joined by my colleague Chintan Shah, and we're very excited to show you why you should consider the TAO Toolkit to train, adapt, and optimize your AI models. AI is hard, and AI workflows are complex and time-consuming. They are complex because they require the collaboration of different personas, with each role having its own set of challenges. Essentially, it's a team sport, and everyone on the team has to have a defined role and a common goal. Let's walk through a typical process at a very high level. The first step is data collection. We all know that the data is the new oil. However, data comes in many different types that then needs to be labeled, annotated, and in some cases augmented as well. This is typically done by a data engineer. The next step is training a model. Training a model involves creating or adapting a model that can make the desired prediction. You start by either choosing from an existing library or building from scratch, and then train and optimize it for a certain task or use case. For example, detecting people in a busy intersection for public safety purposes, or building a model that can translate languages. The model then is integrated into an app, either by building or deploying an API or some other service. And finally, it's deployed into production, where you monitor it and ensure that the application is delivering at the right throughput and latency. As simplistic as my workflow looks from left to right, none of these tasks are easy, all the way from gathering the data to training the model to deploying the model. There's so many challenges at every step of the workflow, but for the sake of our discussion today, we'll keep the focus on the training part. I'll start again with data. To train deep learning models from scratch, you need mountains of data to achieve the right accuracy and performance. For some of our computer vision models here at NVIDIA that we've trained, it took millions of images to achieve the right accuracy. So at the end of the day, you need tons and tons of data. And in some cases, that data may be restricted in your case, or maybe you just don't have enough of the data to train from scratch. So that's issue number one. The second issue that you'll run into is finding the trustworthy sources for models. If you search on the internet today, you'll find many repos that provide AI models. That's great. These are built by people who have shared their incredible work with others. And even though the community aspect is wonderful for the growth of AI, there are many concerns when it comes to actually deploying these models into production. Some questions may be, what are the data sets that these models were trained on? What's the accuracy of this model? Are these models production ready, or do I need to actually put a lot more effort to make them production ready? How easy is this for me to integrate these models into my existing application or workflows? How easy it is for me to fine-tune these models with my own corpus of data? And you may have several other questions on top of these questions that I've listed. So now the question becomes, how do you find the right model for your right use case, and are these models trustworthy? The third issue is skills. We talked about that training is a very iterative process and requires deep knowledge of building AI. Typically, a data scientist, or in some cases, an army of data scientists with the right experience, know how to build a model. They go through several iterations by tweaking and changing the various knobs and dials and eventually arriving at a model that meets their criteria. We interviewed nearly 700 enterprises to learn about their challenges. And it was no surprise that they cited that lack of data, or lack of large data sets, and lack of skills in their staff were key blockers when it came to pushing their AI initiatives. Now, if you think about how difficult it is to just get one model fine-tuned and deployed in production, think about the proliferation of use cases that you'll face. A generic model can only deliver value if it can be trained on your data. But there's infinite diversity of applications, domains, environments, and specializations. So what do I mean by that? Well, take, for instance, industrial manufacturing. There are a variety of use cases and solutions where AI can be applied. For example, AI-enabled inspection helps you increase yield, helps you provide consistent quality for your products, reduces your manual reinspection. Optical inspection is 20% of the manufacturing workflow and nearly 30% of the manufacturing costs. What that really means is that if you can detect the defects in parts early enough, you can save tons of money. Think about a second use case in industrial manufacturing, worker safety. This is big. This is a big deal. The International Labour Organization states more than 2.8 million people die as a result of work-related diseases or occupational accidents per year. That's a staggering statistic. By tracking indicators of physical fitness like heartbeat or skin temperature, sensors can help watch out for employees who are starting to show strain or other signs of potential problems and take preventive action before anything else happens. Take, for instance, process automation. That can include augmenting employee capabilities by offloading certain portions of their tasks. This frequently means extracting information from systems and documents and then preparing them and making them ready for the employee whenever they need it. A good example is when a technician is out at the remote site and needs up-to-date information to, say, fix a machine. He or she can then interact with a chatbot that can help them in real time. So we talked about all these different challenges when it comes to collecting the data, having not enough data, not enough skills to build these models. So what are we doing from an NVIDIA perspective to help you overcome those challenges? Well, first thing is that we built the NVIDIA TAO Toolkit that lets you train, adapt, and optimize AI models for a specific task with your custom data. At the core of it, the TAO Toolkit is a CLI-based Jupyter Notebook solution, where we've abstracted away the need for you to spend hours and hours writing AI code. So let's talk about how it actually works. You first start with an NVIDIA optimized model architecture, such as the likes of ResNet or YOLO. Or you can pick one of the many pre-trained models in computer vision, such as PeopleNet, license plate detection, or in the case of conversational AI, question answering or speech recognition. So you have two separate paths as to where you can get started with. In the second step, you bring your own data to train with the TAO Toolkit. Now, compared to training from scratch, you only need a fraction of the data here. Well, what's the reason for that? Again, the TAO Toolkit has transfer learning built into it, where essentially you train the features from an existing neural network model to a new one. Not only that, there are other features such as online and offline data augmentation, something that Chintan will cover later on in this talk. But it's not just about fine-tuning a model, it's also about optimizing for inference. And with built-in pruning and quantization-aware training, you can achieve up to 2x the speed with int8 precision while maintaining the accuracy of FP16. And guess what? All this can be achieved in the TAO Toolkit without AI expertise. You simply provide directives or train your model by accessing Jupyter Notebooks. One thing I'd also like to point out is that the TAO Toolkit can work where your data and computer reside. So if you're running systems and your data is stored on-prem, bring TAO Toolkit to where your data resides and where your computer resides. Or you can also move it in the cloud. Lastly, the optimized model can be deployed via many different deployment frameworks. For computer vision applications, you can deploy it via DeepStream. For conversational AI applications, you would use Riva. Or simply deploy the model with Trident Inference Server with an endpoint API. The key takeaway is that with the TAO Toolkit, you can easily fine-tune models in hours rather than months. So now if the TAO Toolkit is the vehicle, then let's talk a little bit about the models, which are essentially the fuel. Let's start first with the 100 plus combinations of model architectures that are compatible with the TAO Toolkit. This exhaustive matrix below shows all the different combinations and permutations that are possible with the TAO Toolkit. This provides the flexibility for you to build models for most computer vision use cases, all the way from image classification to object detection to complex segmentation tasks. We support most of the popular networks like YOLO v3, v4, Faster RCNN, and EfficientNet. You can also build shallow networks for embedded applications using something like ResNet 10 or MobileNet, or heavier networks for data center and enterprise use cases. A quick note on this one. If you pick one of the NVIDIA optimized model architectures, then you simply have to retrain that model with your dataset again. But fear not, because these models have been optimized for NVIDIA GPUs, you can use built-in features such as AMP or even take advantage of multi-node training to train faster. Now, the second class of models that I like to talk about are what we call the purpose-built models. Again, these include the likes of people detection, pose estimation, license plate readers, gaze estimation, and many other more. You'll see here that we have more than 15 plus models, and over time, we'll be investing more and more time and and resources to add more models to the TAO Toolkit. Let's first talk about the accuracy. The chart shows the out-of-the-box accuracy for most of these models. So what's cool about this is that you can take these models as is in production or fine-tune them quite easily with the TAO Toolkit with your own data. Additionally, the table below shows how these perform on the various GPUs, all the way from the smallest nano to our flagship GPU, the A100. So now if you're running applications at the edge, or if you want to run a data center, you actually know what output you can expect to get from these models. So a lot of our conversation so far has been on computer vision. Let me shift a little bit to the conversational AI side of things, because that's also a key piece of what the TAO Toolkit supports. Our goal is to support the models that can be fine-tuned across the entire conversational AI pipeline. Imagine a use case where you want to build a service to capture speech, understand the question, and then answer from your chatbot. So AI has to first recognize the spoken words, converting audio bits to text using ASR. For that, we have several models such as Jasper and CitrusNet for automatic speech recognition. Once the text is synthesized, AI has to understand the punctuation, the intent, name recognition, and many more. So for that, we have NLP models supporting the TAO Toolkit such as BERT question answering, BERT NER, and many more. And finally, once you have your answer and you want to push it back to the user, you simply use the text-to-speech functionality. And again, we have fast-pitch models or hi-fi GAN model that can be supported to make a machine sound more human. So again, supporting the entire pipeline all the way from speech recognition to NLP to text-to-speech. And all these different models can then be embedded within Riva for a full end-to-end pipeline deployment. Finally, I wanted to leave you with the overall TAO solution stack. For the sake of our talk today, we spoke primarily about the TAO Toolkit. It's an integral part of the overall NVIDIA TAO solution stack, which is an AI model adaptation solution. We are currently in the process of adding a UI layer with the guided workflow and including many other services in the backend. What that really means is that whatever is easy today is going to get a lot more easier. If you want to learn more, feel free to attend the session titled A Zero-Code Framework for Creating Production-Ready AI Models. And you'll see a live demo of what the product will look like in the future. With that, I'll pass it over to Chintan, who will talk about what's new in the current release of the TAO Toolkit and many other features. Chintan, over to you.
Thank you, Akhil. Hello, everyone. My name is Chintan Shah, and I'm the product manager of TAO Toolkit. Today, I'm going to talk about what's coming in our latest release of TAO Toolkit. Just as an FYI, our newest version will be released later this month. Up until now, we've been solely focused on applying AI on images. This is useful in identifying objects, but doesn't tell you anything beyond that. To truly extract intelligence, you need to look at context. You need to look at the temporal information. Instead of focusing on single frame, look at inconsecutive frames. This provides the temporal element. This can help you understand beyond detecting a person or an object. It can help you understand what the person is doing. Recognizing action is applicable in lots of industries. For smart hospitals, detecting and recognizing actions can help understand if the patient is in need of medical attention. On a factory floor, this can help monitor tasks of factory workers. For an autonomous retail store, actions can help understand if a shopper is picking up an object, putting it in his shopping cart, or putting it back in the shelf. The proliferation of use cases are everywhere. And we're happy to announce support for action recognition in our latest TAO Toolkit release. We'll be releasing a 2D and a 3D convolution network along with an optical flow model. Model architectures for both 2D and 3D are similar. In the 2D model, you multiply the number of frames, or D, with the channel count, or C parameter. The channel dimension will now be C times number of frames that we're sampling. For a 3D model, we add a new dimension to our existing height, width, and channel dimension. This new dimension represents the temporal information. The output of both convolution network goes into a fully connected layer, followed by a softmax layer to classify the actions. But the best part is, all of these complexities is handled by TAO Toolkit, and you as a user Just specify the model architecture that you want to use. We'll also be releasing a sample 5-class model to recognize common actions like walking, running, falling down, etc. Both of our 2D and 3D model provide good accuracy on the sample 5-class model. The 2D model is optimized for inference with comparable accuracy as the 3D model. Now, let's take a look at the short demo that walks through all the steps of training and deploying an action recognition model using TAO Toolkit. In this demo, I'll show you how to train a simple 3-class action recognition model that can recognize exercises like push-up, pull-up, and sit-ups. There are only a few things that you need to change to train your own action recognition model. Now, let's get started. Fire up the Jupyter notebooks, and all the commands will be run directly from the notebook. First few steps are basic installation, which are typically common across all of our models. Once you do that, next, download the dataset for training. For this demo, we'll use the HMDB 51 dataset, which has labeled data for 51 actions, but we'll use only 3. Next, download the pre-trained model from NGC. We provided a 2D and a 3D model. For this demo, we'll use the 3D action recognition model. Now, let's customize for our classes. We'll modify the training config file to add our 3 classes. We're going to leave all other parameters untouched, but you can experiment with other training configs like learning rate, batch size, epochs, etc. Let's train our custom model. To train, it's a simple train command. You specify your config file that you modified in a previous step, specify the output directory, and then run the command. This can take few hours depending on the GPU. We're training for 50 epochs and it took about 2 hours on our GPU. Next, evaluate the model for accuracy using the TAO evaluate command. As you can see, we've reached fairly decent accuracy with only 100 samples per class. Let's see how this model predicts on view of our sample videos. The output shown on the screen is the predicted label from the model. The final step in our training pipeline is exporting the model for deployment. Now, let's run our model with DeepStream. Here's a video of me doing exercises at home. As you can see, it's able to successfully predict all 3 actions. The predicted label is in the upper left-hand corner. I just demonstrated how simple it is to train a 3-class action recognition model to recognize simple exercises. I just have to change the class label. It's as simple as that. No coding, no need to learn TensorFlow, PyTorch, or any deep learning framework. You download the notebook, download the model, bring your dataset, train, and deploy. That's it. By the way, I'm not a technical expert, and I was able to train the network in only a few hours. In fact, it took me a lot longer to put this demo together than creating the custom action recognition model. I do want to show you what all you can customize to help you get the best model. In the model parameter config, you can select between a 2D or 3D model depending on accuracy and performance KPIs. You can also specify what backbones you want to use. You can choose any ResNet-based feature extractor, from ResNet 18 all the way to ResNet 152. If you have large number of classes, large data set, and you're shooting for high accuracy, you can go as deep as ResNet 101 or 152. If you're looking for inference performance, you can go with the shallower networks. You can also specify training parameters like learning rate, number of epochs, checkpoint interval, and many more under the training configuration. And finally, to customize for your classes, modify the dataset config, specify what classes you want to train for, along with the resolution, batch size, etc. Action recognition is a complex model. It takes into account the temporal information, but we have simplified the training into a handful of options. So try out the new model once it's released. We're constantly tweaking and improving our models to reduce training time. One way is by making sure that our models are able to fully utilize the entire GPU. Reducing training time will reduce your overall training cost. There are few factors that affect your overall utilization. Size of the model. More parameters you have, you'll be able to achieve higher utilization. Batch size. How much parallel data that you are providing to your model in a single pass. Resolution of the model. Lower res model might not optimize as well as a larger model. And lastly, the GPU that you are using. One set of hyperparameters might be optimal for a V100 GPU, but might not be optimal for an A100 GPU. So to get the maximum utilization, you'll have to experiment with few hyperparameters on the hardware that you're training on. Here are a few GPU utilization numbers for few of our popular networks on V100. But you can also get comparable numbers on an A100 or any other GPU. We can achieve at least 70% or higher on most of the networks, and for some, we approach close to 90%. This means that if you're trained with TAO, you're guaranteed that you'll be able to train your network in most efficient way possible. You'll be able to train more in less amount of time. Data augmentation is very important for any training job. It allows you to add variation in the data that always helps in generalizing. TAO Toolkit supports both offline and online augmentation. Offline augmentation is typically used when you have a small data set and when you want to inject noise, variation to increase the overall size of the data set. For example, a 10 image data set can be augmented to 100 image data set. Online augmentation is used during the training when the entire data set is randomly augmented during each pass through the network. This ensures that from epoch to epoch, there's some data change that will help the model generalize. For TAO Toolkit, 3 main augmentation types are supported: image blurring, spatial augmentation, and color augmentation. For spatial augmentation, TAO Toolkit supports image rotation, vertical, horizontal flip, and many more. For color augmentation, TAO Toolkit supports brightness adjustment, hue rotation, saturation shift in the image, and contrast adjustment. So we ran few experiments on a small data set of 100 images and 500 images. We took a small 100 image data set and applied both offline augmentation and online augmentation to see how much accuracy we can improve by augmentation. For a 100 image experiment, without any augmentation, we're able to achieve only 36% MAP, or mean average precision, which is basically useless. As we started augmenting more images from the same 100 image dataset, we started seeing significant increase in accuracy. When we augment the same 100 images by 20x and also added online augmentation, we're all of a sudden able to achieve 79% MAP, which is more than double of our original 100 image dataset. This shows that augmentation is extremely beneficial, especially when you have a limited dataset. On a 500 image experiment, we were able to increase the accuracy by 13%, going from without augmentation to with augmentation. Significant increase nonetheless. We have published this experiment in our white paper with a code to replicate this in our GitHub repo. One of the most common questions that we get is, can I train PeopleNet model or any other pre-trained model for low light images or for different camera types? Or is there a benefit in using NVIDIA pre-trained models? One of the experiments that we did was we fine-tuned our existing PeopleNet model on a thermal IR dataset. This is from a thermal camera which uses infrared frequencies. The image from thermal camera would look something like the image on the upper right-hand corner. This looks very different than RGB images that were used to train this model. In parallel, we also trained this dataset using some pre-trained weights from one of the supported model architectures in TAO Toolkit. We quickly found out that PeopleNet converged much more quicker than if we are not using PeopleNet. With about 1200 images, we're able to get 66% accuracy on our test dataset versus less than 45% if you were using without PeopleNet. Even when we added more data, existing features that PeopleNet has learned provided a higher accuracy. At 6,000 images, fine-tuned PeopleNet model provided 6% higher accuracy than without PeopleNet. This experiment proves that with PeopleNet or other pre-trained models, you can converge faster, train faster with less data. You can easily fine-tune existing models to learn on different camera types, different vantage points, etc. You can also fine-tune existing models to add new classes. Let's say you have a model that detects people and faces, such as PeopleNet, and now we want to use it to see if the person is wearing a helmet or not. Think of worker safety use case, where you want to detect if workers are wearing a safety hat or not, like on a construction site or a factory floor. Now to detect all three classes, helmets, people, and faces, you need to provide a dataset which has labeled data for all the three classes. But if your dataset only consisted of labeled data for helmet, then you can use TAO Toolkit inference to detect and pre-label person and face class on the helmet dataset. Now you can add the people and face annotation to the existing helmet dataset and use this complete dataset to train your new model with TAO. The original model was already trained on people and faces, so you can reduce the weights for these classes and put a higher weight on the helmet class, since the model has never seen this data before. Once you do that, the model will start converging for the helmet class even if you have limited dataset. In the experiments that we ran, we were able to get up to 80% accuracy for helmet class with only a few thousand images. This shows TAO Toolkit is fully extensible for custom use cases. Data curation and labeling is very important aspects of any AI. This could be labeling on the data that you have, as well as generating new data using synthetic data platforms and game engines. Synthetic data can help fill in the gap where data collection and labeling is difficult and expensive. We're happy to announce our partnership with several leading data labeling and synthetic data generation companies. You can use our partners platform to generate and label your data and then directly integrate into TAO Toolkit. Many of our partners have published blogs which walk through steps of integrating data from their platform into TAO Toolkit. Visit our product page to learn more. I want to share with you a few of our partner success stories who have successfully created AI products using TAO Toolkit. We have partners who have built manufacturing solutions, agriculture solutions, retail solutions, and many more. One of our partners, Boston Server and Storage Group, was able to use TAO Toolkit for an inspection use case to detect and identify welding defects. They were able to accelerate their AI development and get a very high accuracy model using TAO Toolkit. Recycle Ai, a startup who's building automated waste management solutions. They built a model to detect objects on a fast-moving conveyor belts. TAO Toolkit helped them speed up AI development. Aruga, a startup who's changing agriculture, built a robot that rides on track between rows of plant that capture images of every flower, and then run their AI algorithm to instantly determine flowers' readiness to be pollinated. They were able to integrate TAO Toolkit into their solution to increase their crop yield. And lastly, Tristic AI is doing fantastic work in the retail space. They're using AI to detect apparels on people, and using that information, it's able to assign unique identifiers on each person without doing any facial analytics. TAO Toolkit has helped them reduce their development time from days to months. The common theme across most of our partners has been TAO has enabled them to go faster and reduce their development time. They don't have to deal with the complexities of building AI. They can leverage the pre-trained models from TAO to build their custom solution. AI is a very iterative process, starting from data preparation to training to deployment, and then once deployed, continuously improving the AI using the data from the field. TAO Toolkit accelerates the training portions of this journey, which can be time-consuming and arduous. To summarize, why TAO Toolkit should absolutely be part of your AI journey. First, the simplified Jupyter Notebook makes it super easy to get started. You don't need to be an AI expert, as you saw in the action recognition demo. No need to learn complex AI frameworks, model architectures. Just modify a few things and get started. Second, the pre-trained model provides a great starting point to train your own custom AI. Just apply minimum fine-tuning to customize your model to your vantage point to your camera type. Lastly, we have optimized the heck out of our models, especially for inference. And if you use TAO, you'll be able to apply quantization, pruning to get the best performing model for inference and deployment. So what are you waiting for? Get started today with TAO Toolkit and start accelerating your AI development. Here are a few important TAO Toolkit resources. From the product page and the Getting Started page, you'll be able to navigate to all the blogs, documentation, and all the other resources. Now we'll open up for our live Q&A session.